Today we're going to learn how to solve systems of equations in 3 variables, and you have to have 3 equations to do that. We're going to use elimination to solve this system of equations, and the first thing to do is to choose which variable to get rid of. So I'm noticing that I have a plus 3z here and a minus 3z here, so let's get rid of z first. I'm going to label this equation 1, this equation 2, and this equation 3 so we can keep track of what we're doing. Okay, I'm going to add equation 1 to equation 3, and that will get rid of the 3 z's. So I have x minus 2y plus 3z equals 5, and the third equation, 5x plus y minus 3z equals 3. Let's add them up. I'm going to get 6x minus y, the 3z's cancel, equals 8. So now I have one equation in terms of x and y. I need one more equation in terms of x and y, and I need to bring in equation 2. So I'm going to multiply equation 2 by 3 to give me a 3z right there and add it to equation 3. Okay, so let's do that. I'm going to have 3 times equation 2 plus equation 3. So equation 2 times 3 is going to give me 9x minus 9y plus 3z equals 27. And I'm going to add that to equation 3. 5x plus y minus 3z equals 3. That'll give me 14x minus 8y, the z's cancel, equals 30. Now if you can, it's always good to reduce your equations. Notice I can divide everything here by 2, so that'll give me 7x minus 4y equals 15. Okay, so here's what we have now. We've gone from, I'd like to do a different color here. Okay, so we've gone from 3 equations with 3 variables down to 2 equations with 2 variables. So now I'm going to use elimination to get rid of one of those variables, either x or y, and I think I'll get rid of y. So I'm going to multiply this top equation here by, let's say negative 4. So I'm going to get negative 24x plus 4y equals negative 32. And I'm going to add that to this equation down here. 7x minus 4y equals 15. Okay, add them up. I get negative 17x, the y's cancel, and negative 32 plus 15 is negative 17. So x is 1. Okay, now what are we going to do with that? Well, I can plug this x value into either this equation up here or this equation right there. It doesn't matter. So let's do that. I'm going to go into, let's put it into this one right here, up the 6x minus y. So I get 6 times 1 minus y equals 8. So minus y equals 2, because I'm subtracting 6 from both sides. So y equals negative 2. Okay, so we have x and y. We're not done yet. I need to find z. So I'm going to plug that into any one of these original equations up here. I'll plug it into the second one because that has z by itself right there. Okay, so here we go. 3 times 1 minus 3 times negative 2 plus z equals 9. So that's 3 plus 6 plus z equals 9. 9 plus z equals 9. Z equals 0. So our answer is an ordered triple, 1 for x, negative 2 for y, and 0 for z. So to recap, what you want to do is decide right off the bat which variable you want to get rid of first, and you get rid of the same variable twice. We chose to get rid of z here and here, which gave us 2 equations with x and y. Now you can also use a system of equations to find a quadratic equation. So we would like to find the equation y equals ax squared plus bx plus c, whose graph passes through the points 2, 3, negative 2, 7, and 1, negative 2. In other words, the parabola that contains those 3 points. Now what each point says is when x is 2, y is 3, and this point tells us that when x is negative 2, y is 7, and this point tells us that when x is 1, y is negative 2. So let's just put that information in. Let's do the first point. It says that y is 3 when x is 2. So everywhere there's an x, I'm going to put in a 2. And from that, I get the equation 3 equals 4a plus 2b plus c. My second point says y is 7 when x is negative 2. So that equation says 7 equals, that should be a squared, 4a minus 2b plus c. And finally, the last equation says y is negative 2 when x is 1. And so we get negative 2 equals 1a plus 1b plus c. So here are our equations. There's equation 1, equation 2, equation 3. Which variable should we get rid of? It really doesn't matter. Let's get rid of b just to be different, okay? So I'm going to add equation 1 to equation 2, and that'll be 3 equals 4a plus 2b plus c, and 7 equals 4a minus 2b plus c. I'll get 10 equals 8a, the b's cancel, plus 2c. Always reduce if you can. I can take a 2 out, so I get 5 equals 4a plus c. Okay, so let's hold on to that equation. Now I need to get rid of b again using equation 3. So let's add equation 2 plus twice equation 3. Alright, so equation 2 plus 2 times equation 3. Okay, 7 equals 4a minus 2b plus c. And then I'm going to multiply this by 2, so I get negative 4 equals 2a plus 2b plus 2c. So you see how it works out. My b's are going to cancel again. So 7 minus 4 is 3. 4a plus 2a is 6a. B's are gone. C plus 2c is 3c. Once again, I can reduce by 3. So 1 equals 2a plus c. Okay, so now we are going to combine this equation and this equation. Why don't we get rid of c, and that'll help us find a. So I have 5 equals 4a plus c, and I'm going to just multiply all of this by negative 1. Negative 1 equals negative 2a minus c, so I get 4 equals 2a. Therefore, a equals 2. Now, I can take that and plug it in up there. So I'm going to get 1 equals 2 times 2 plus c. 1 equals 4 plus c. C equals negative 3. I know a and c. I can plug that into, shall we put it into this third equation right here? Okay, so negative 2 equals a plus b plus c. And we'll find b. So negative 2 equals negative 1 plus b. Negative 1 equals b. Alright, so remember, the whole point of this was to figure out what a, b, and c are for that equation up there. So here's the parabola that contains those 3 points. Y equals 2x squared minus x minus 3. And that parabola will contain these 3 points up here.